this video, I'll talk about how to convert different numbers to different bases. For instance, converting a hexadecimal to a binary or binary to decimal and so on and so forth. So let's start with converting from binary to hexadecimal, from binary. So binary just means it has either 0 or 1, and also it's called base 2. And I would recommend watching a previous video I made on how to convert from decimal to binary or binary to decimal. So from binary to hexadecimal. Basically, hexadecimal, it's base 16. So computers work with zeros and ones, but for humans it's a lot easier to represent binary as hexadecimals. So it's easier for humans to represent binary as hexadecimal, and we will see why. Hexadecimal numbers, basically, because when you have a binary number, it's just a bunch of ones and zeros, and it's not like it's 100, and it's not like 1,100,011. It's just a bunch of ones and zeros. So we'll see how we can take this and represent it as a hexadecimal, which is kind of easier to work with. So first, let me go through a table that shows. So if we have decimal, then binary, then hexadecimal. So obviously decimal, you start with 0, 1, 2, 3, 4, 5, 6, 7, 8, and you stop at 9. Then, or you can go actually 11, 12, because hexa goes up to 15. So 11, 12, so on and so forth. So binary, 0 basically is just four zeros, 1 is just 3 zeros and 1, 2, 0, 1, 1, so on and so forth. Hexa, basically 0 is just 0, 1 is just 1, 2, it's kind of like decimal, basically 3, 4, 5, 6, 7, 8, 9, 10 is the same as 10, so 9, then it goes A. 10 is A. So A, then 11 decimal is B in hexa, 12 is C, 13 is D, 14 is E, and 15. So A is hex in base 16, which is hexadecimal. It's the equivalent of 10 base 10 decimal, basically. B is the equivalent of 11 in base 10 or decimal. C is 12 D is 13. E is the equivalent of 14 in decimal, and F is the equivalent of 15 in decimal. Then 16, you would just write 1 F. Okay. Let's just stop at 15 and we'll see how we can use them. So to convert a binary number to hexadecimal, so start from the right of the binary, and group the bits, or the bits, we said zeros and ones are called bits, in groups of 4. So four bits basically at a time, and replace each 4 bits or bit group, 4-bit group with the equivalent hexadecimal. So let's assume we have this binary number we want to convert. So 1 0 0 1 1 1 1 1 0 1 0 1. This is in base 2. We want to convert it to hexadecimal. So the first step is we'll group these in 4 bits, 1 2 3 4. So here's the first group. So we'll always you start from the right. You go this way. 1 2 3 4. Here's another group. 1 2 3 4. Here's another group. So if you go back to that table, this is basically you have 1. This would be 2, 4. So 4 plus 1 is just 5 hexa. And this would be 15, which is F. And this would be, so 1 2 4 8. 8 plus 1 is 9. So the equivalent of that binary number is in hexa is 9F5. Now let's convert 29B hexa to binary. So how do you tackle this? You just write the number here. So this is in hexa or base 16. So what is B? From that table that I was going through is 11 decimal, or it's 1 0 1 1. So basically if you convert this to decimal, this would be 1, this would be 2, this would be 4, but it's 0 times 4 is 0. This would be 8. So 8 plus 2 is 10, plus 1 is 11 decimal, which is B hexa. So 9 would be 1 0 0 1, and 2 would be 0, 0, 1, 0. So if you group them all together, you get 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 1. So that's space 2. But obviously, if you write this, you will drop the leading zeros. You don't need to show them. Since they're leading, they don't do anything. Obviously, you can leave them, but typically they are dropped. So now, let's convert 45 in a decimal. This is a decimal number or base 10 to hexadecimal. So you can convert 45 base 10 to binary first, then you can convert the binary to hex, or you can convert directly from decimal to hex. Convert from decimal to hexadecimal directly by repeated division. By repeated division, keeping track of the remainders. Keeping track of the remainders. And I would recommend watching the previous video that I made how to convert from decimal to binary. And I'll go through this example. So here's what I will do. I'll convert from decimal to binary, then binary. So basically I'll start with option 1. Convert 45 to binary, then binary to hexa. So I'll use repeated division. So what you do, you take 45 divided by the base you want to convert to, which is binary. So 45 divided by 2 is 22, and we keep track of the remainder. So remainder of 1. And just remember, this is the least significant bit. Then 22 divided by 2 is 11. The remainder is 0. 11 divided by 2 is 5. The remainder is 1. 5 divided by 2 is 2. Remainder of 1. 2 divided by 2 is 1. The remainder is 0. 1 divided by 2 is 0. The remainder is 1. And this is the most significant bit. And the way you write these from most significant bit to least significant bit. So basically you start with this. So 1, 0, 1, 1, 0. So this is the equivalent of 45. So 45 in base 10 is the equivalent of 1, 0, 1, 1, 0 in base 2. Sorry, I left out the 1 here. So 1, because there is a 1 here. So in other words, 45, or actually, let me go to the next page. So I found that 45 base 10 is the equivalent of 1, 0, 1, 1, 0, 1 base 2. So, and to convert the binary to hexa, you just group from the right. You start from the right and you group in 4 bits. And since this one just has 2, I'll just add 2 leading zeros. So this is 1, 2, 4, 8. 8 plus 4 is 12, plus 1 is 13, and 13 is D in hexa, and this is just 2. So this is the equivalent in hexa. So 45 decimal is the equivalent of 2D in base 16 or hexa. Now I can show how to convert this directly to hexa. So the second option is convert 45 base 10 directly to hexadecimal. So I have 45 and the base that I want to convert to is 16. So I'll just divide 45 by 16 is 2, and I keep track of the remainders. So I have 13 as a remainder. 13 in base 10, which is equivalent of D in hexa. And remember, this is the least significant bit. So then 2, so you just bring 2 divided by 16 is equal to 0. So the remainder is 2. So 2 hexa. And this is the most significant bit. So you write it from most significant bit to least significant bit. So the most significant bit is 2, and the least significant bit is D. So I got the same answer basically. So you have two ways. You can go through, so base 10 to base 2, then base 16, or you go straight from base 10 to base 16. Let's do another example. Convert 75 base 10 to hexa. So I'll convert it to base 2 or binary, then group them in four bits starting from the right to convert to hexa. So 75 divided by 2 is 37, remainder is 1. This is the least significant bit. Then 37 divided by 2 is 18, remainder is 1. 18 divided by 2 is 9, remainder is 0. 9 divided by 2 is 4, the remainder is 1. 4 divided by 2 is 2, remainder is 0. 2 divided by 2 is 1, remainder is 0. 1 divided by 2 is 0, remainder is 1. This is the most significant bit. So we write from most significant bit to least significant bit. That means I'll start with this one here. So 1, 0, 0, 1, 0, 1, 1. That's base 2. So 1, 0, 0, 1, 0, okay. So then I just group them in 4 bits. So this is, you have 1 plus 2 plus 8, that's 11, which is B in base 16. And I can add a leading 0 here to make it 4. This is just 4. So 4B. So 75 in base 10 is just 4B in base 16 or hexa. Let's go directly from base 10 to base 16. Basically take 75 divided by 16. Basically you take the number you're trying to convert divided by the base you want to convert to, which is 16 hexa. So that's 4. The remainder is 11. in decimal, which is B in hexa. This is the least significant bit. So then 4 divided by 16 is 0, and the remainder is 4. So this is the most significant bit. So you write from most significant bit to least significant bit for B. So I got the same answer. So if I have this for B in base 16 and I want to convert it to decimal, which basically in this case it should be 75, base 10. Let's verify how we do that. So what is B? B is 11 in decimal. So 11 times 16 to the power of 0, because B is in position 0, 4 is in position 1, plus 4 times 16, which is a base, to the power of 1. So 4 times 16 is 64, plus 11 times 16 to the power of 0, just 1. So that's just 11, which is 75, base 10. That's how you verify if your answer is correct or not. Thank you and have a great day.